Hello everyone. Today we are going to discuss the third problem of Leetcode Weekly contest 383, which is find the grid of region average. So we are given some grid of M cross N, uh, and there are some definitions given to here. A region is a 3 cross 3 subgrid of the original grid, where absolute difference between any two adjacent characters are less than or equal to some threshold. Now we have to take the for every cell we have to take the average of the regions it belongs to, right? So let's say for this grid there are two regions. One is the 3 cross 3 grid starting from the 0 comma 0th index, and the second one is the second region which starts from 0 comma 1. Now we will take let's say we will take the average of some region. The average of the first region is what? The average of the first region, if we calculate, it will be around 9. Okay, and the average of the second region, if we round it down, it will also be 9. Now we will check that what the first character belongs to. The first pixel belongs to only the first region. Similarly, this pixel also belongs to the first region. This pixel also belongs to the first region. So the values will be 9, 9 and 9. Now similarly, these three pixels, this and this, they also belong to the second region. So we'll take their value as 9. Now for these six, the inner six pixels, they also belong to the first region and they also belong to the second region. So we'll take the average of the two regions and put them into these cells. So as the average is 9 in both, so the average pixel in these two will also be, these six cells will also be 9. So all the values will be 9. Now if we take the second case, you will understand it better. Here there are two regions, the first region and the second region. Now here you can see that for the inner two cells, these two rows, the intensity values are different. 27 for the first three cells, the intensity values are 25, and for the last row the intensity value is 30. So here you can see that how being in different regions impacting the intensity values. So how we can solve this problem, right? So for solving this problem, let's look at the time complexity first. So n and m is 500. So here what are the possible time complexities? The possible time complexities will be something like order of n into m, or order of n m into some constant, right? So let's look at some observations. So the first observation, there are not much observation in the problem. The problem is like implementation heavy. What we have to do, we have to find the average in every region, and after finding the average in every region, uh, we have to mark every cell which is in some region. So how I have solved this problem, I will show you my approach. My approach is right, we will take some race will be nothing but n into m into 2. So what race ij0 identifies? So let me write in text format. Race ij0, the ij0 identified the total score the current region belongs to. Current cell I comma j belongs to total score of regions. Okay, total score of regions the current cell belongs to. And what is race ij1? Race ij1 is nothing but number of regions the current cell belongs to, number of regions I comma j belongs to. Okay, so if we have found that race ij0 and race ij1, then we can say image of ij, the final value of image ij will be nothing but race ij0 by race ij1, right? Now there will be some cases where we have to check that if race ij1 is 0, that means the current cell is not belonging to any of the regions. So here we can say if race ij1 race ij1 is greater than 0, then then only we can take this function, otherwise it will be image ij. right? This is the algorithm, there is nothing else. So you take race ij0 as the total score of regions the current cell ij belongs to, and race ij1 the number of regions the cell current cell belongs to. Now if image ij is race ij0 by race ij1, if this is greater than 0, otherwise it will be the original value of image ij. Okay, now let's look at how we can calculate race ij0 and race ij1. So we'll check every region. Okay, so there will be so we'll take the starting cells, right? So let's say our cell is like that, our grid is like that, grid is like that, 4 cross 4. Now we'll take every starting cell. This could be a starting cell because this grid is possible. This could be a starting cell because this grid is possible. So starting cells could be this or this. There is a starting cell because this grid is possible, and this is also a starting cell because this grid is possible. So we'll check for every starting cell. We'll take the 3 cross 3 region starting from this index, and we'll check if this is a region or not. For being a region, the conditions has to satisfy is that all the adjacent cells, the difference between them should be less than threshold. If this is a region, then we will add the average of this region to each of the cell in the region. Okay, so let's look at the code, you'll understand it better. Now we are taking the every starting cell of the region. The starting cell could be from n minus 2. The rows could be I less than n minus 2, and j the number of columns should be n minus 2. So we are taking the starting cell of the region as I comma j, and here we are checking that for every cell, for every cell in the region, so we are taking k 0 to 3 and l 0 to 3. So we'll have I plus k and j plus l, our current cell in the region. Okay, and we are taking all its neighbors. So for a cell I comma k and j comma l, we are checking all its neighbors that belongs to this region. For belonging to this region, the condition is that let's say some cell p comma q belongs to the current region. The condition is that I should be less than equals to p and less than I plus 3, and because the values of rows could be I plus 1, I plus 2, and similarly the values of columns could be j plus 1, j plus 2. So the condition is that p should be from I to I plus 3, and q should be from j to j plus 2. So this is the condition. So here what I am checking is that for every neighbor of I plus k and j plus l, that is our current cell, I plus k and j plus l our current cell, we are checking for each of its neighbor. If the neighbor belongs to the current region, we are checking if their absolute difference is greater than threshold. That means this is not a region, the current starting cell will not be a part of region, so we are making it flag as 1, and we are coming out of the loop. So here is the out of the loop. So the loop starts from here, so we are taking coming out of the loop. Okay, now if flag equals to 0, that means the current cell is a region, because if flag equals to 1, that means our current cell is not a region. So that's why we are taking c by equals to 9, because there are 9 cells in the region and c is the sum of all of them. So we are taking c as average, and we are adding c is the race ij0, and adding incrementing the value of 1, the number of regions this current cell belongs to, and at the end we are doing this image ij is race ij0 by race ij1 if it is greater than 1. If it is not, if it is equals to 0, then we are not doing this operation, so image ij will be untouched. So I hope you get it. The problem is quite straightforward, only the implementation part is something tricky, but that is also straightforward, I think. I will provide the link of the code in the description box. If you have any doubt in any part of the code or any part of the explanation, you can always ask in the comment section. I will try to reply each and every one of you. If you find this video helpful, please like the video and subscribe to my channel. Thank you.